Good day, everyone. So we are going to discuss the similarities of right triangle. But first, we need to unlock these few words. So what is the meaning of similar? So similar means having the same shape, but not the same position or measurements. How about congruent? So congruent means having essentially the same shape, measurements, and position. So we are going to discuss the difference between similar triangles and congruent triangles. So similar triangles are those triangles whose corresponding sides are in proportion and whose corresponding angles are congruent. In congruent triangles, the measurements of the sides and the angles are all congruent. Got it.
Let us now proceed on the theorems, principles, and similarities of right triangles. Principle 6. Two right triangles are similar if an acute angle of one triangle is congruent to an acute angle of another. Now let us now look on figure 1. According to principle 6, if an acute angle of one triangle is congruent to the acute angle of another triangle, then it follows that they are similar according to the AAA similarity. Principle 7. Triangles similar to the same triangle are similar to each other by transitivity. Principle 8. The altitude drawn to the hypotenuse of a right triangle divides it into two triangles. According to principle 8, if the altitude is drawn to the hypotenuse, then it divides it into two triangles.
We're going to discuss again principle 8. So the altitude drawn to the hypotenuse of a right triangle divides it into two equal triangles. So now let us look on figure 3. So this altitude divides the right triangle into two triangles, in which this triangle is similar to this triangle. And according to principle 7, if two triangles are similar, if one triangle is similar to one triangle and the other triangle is similar to another triangle, then it follows that the first triangle is equal to the last triangle. So this triangle is equal to this triangle and the whole triangle. So now let us discuss the corollary principles. Corollary 1. So the length of the altitude drawn to the hypotenuse of a right triangle is the geometric mean between the length of the segments of the hypotenuse. So as you can see here, the altitude h is drawn to the hypotenuse. So there are two segments created, A and B. So what is the value of h? According to corollary 1, the value of the height is equal to the geometric mean of A and B. Let us move to corollary 2. If the altitude is drawn to the hypotenuse of a right triangle, then either length is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to the legs. Okay, so these are the two legs. So the value of C, the shorter leg, is equal to the geometric mean of the segment near to it, so A, times the sec times the hypotenuse. So the hypotenuse is E. The value of B is equal to the geometric mean of the segment near to it is B times the whole hypotenuse. So that is the end of our discussion about similarities of right triangle. Now let us move to some exercises that we will answer. So this is the first exercise. Find the value of x. So everything that we need to do is simply apply principle 8. First, we need to separate the two triangles created by the altitude. I'm going to flip this so that we can find the corresponding sides. So now we have the corresponding sides. So x is proportional to 6 over 5 and 3 is proportional to 4. So we can just equate this. X over 6 over 5 is equal to 3 over 4. Simplifying this expression. So, cross multiplying. X is equal to 18 over 20 or 9 over 10. So the value of this segment is 9 over 10 units.
So this is the second problem. We are just going to simplify the geometric mean between the segments.
One, two, three, go. Okay, so this is another exercise. So in this figure, the height is x plus 5 units. The first segment is 25 units, and the other segment is 16 units. So what we are going to do is simply find the geometric mean. X plus 5 is equal to the geometric mean of 25 times 16. X plus 5 is equal to the square root of 25 times 16, which is equal to 5 squared times 4 squared, which is equal to 20. So x plus 5 is equal to 20. So we will simply transpose it. So x plus 5 is equal 20. X is equal to 20 minus 5 is equal to 15. So the value of x is 15. So the height is 20 units. That's all.
Problem number 1, we are asked to find line segment YF, line segment XZ, and line segment ZY. We will just simply equate this into 6 squared is equal to x minus 3 times 3. Because on what we have said earlier, the geometric mean is equal to the square root of the product of the segments created by dropping the altitude. So simplifying this, 6 squared is equal to 36. Distribute. Transposing negative 9 on the other side. Dividing both sides by 3. X is equal to 15. So in order to find YF, we will just simply substitute X into this equation. Adding these two line segments, XF and FY, make up this whole line segment, XY. So 3 plus 12 is equal to 15, which is the hypotenuse. To find XZ, we will just simply equate this into XZ is equal to square root of the adjacent side and the hypotenuse. Simplifying this, XZ is equal to square root of 45. just like in xj, this leg is equal to the square root of the product of the adjacent side and the hypotenuse. Applying all the principles and theorems that we discussed, we got yf is equal to 12 units, xj is equal to 3 square root of 5 units, and zy is equal to 6 square root of 5 units.